When we think of dimensions, our minds often drift to science fiction scenarios, parallel universes where alternate realities unfold. However, the scientific concept of dimensions is far more intricate and foundational to our understanding of the universe. Today, we'll embark on a journey through the 10 dimensions as proposed by string theory, unraveling the fabric of our cosmos. The familiar 3 dimensions. We exist in a 3-dimensional world where every object has 1. Length x-axis, 2. Width y-axis, 3. Depth z-axis. These dimensions allow us to pinpoint any location or describe any object in our daily experiences. The 4th dimension, time. Beyond these spatial dimensions lies the 4th dimension, time. Time provides the temporal context, allowing us to sequence events and comprehend motion. Together with the 3 spatial dimensions, time forms the 4-dimensional space-time continuum, a cornerstone of Einstein's theory of relativity. String theory and extra dimensions. String theory, a leading candidate for the theory of everything, suggests that the universe operates in 10 dimensions. This framework aims to reconcile general relativity, which describes gravity, with quantum mechanics, which governs the subatomic realm. For the mathematics of string theory to be consistent, the number of dimensions of spacetime must be 10. The 5th and 6th dimensions, alternate realities. In the 5th dimension, we encounter a plane of possible worlds that share the same initial conditions as our universe, e.g. the Big Bang, differ based on varying outcomes of events. The 6th dimension expands this concept, allowing us to compare and position all possible universes with the same starting conditions. Mastery over these dimensions would, theoretically, enable time travel or exploration of alternate futures. The 7th and 8th dimensions, divergent histories. The 7th dimension introduces worlds with different initial conditions, universes that began differently from our own. The 8th dimension presents a plane of such universes, each branching out infinitely, representing all possible histories and futures. The 9th dimension, laws of physics variations. Here, we can compare universes with entirely different laws of physics and fundamental constants. This dimension encompasses all possible physical realities, each governed by its own set of rules. The 10th dimension, the limit of imagination. The 10th and final dimension encompasses all conceivable and inconceivable possibilities. It's the culmination of all potential universes, histories, and laws of physics, a realm beyond human comprehension. The role of Calabi-Yau manifolds. A perplexing question arises. If extra dimensions exist, why don't we perceive them? String theory proposes that these additional dimensions are compactified into intricate shapes known as Calabi-Yau manifolds. These 6-dimensional structures are folded into our 3-dimensional space, rendering them imperceptible. Despite their invisibility, they profoundly influence the physics of our universe. Understanding these extra dimensions could revolutionize physics, offering insights into the unification of fundamental forces, the nature of dark matter and dark energy, the initial conditions of the universe. However, detecting these dimensions remains a monumental challenge due to their minuscule scale. To delve deeper into this topic, explore resources on string theory and its implications. Engage with visualizations of Calabi-Yau manifolds to grasp their complex geometry. Follow current research in theoretical physics for the latest developments. The concept of 10 dimensions challenges our conventional understanding of reality, inviting us to expand our perception beyond the visible and tangible. As we continue to explore these dimensions, we edge closer to unraveling the true nature of the universe.